Hello everyone and welcome to my channel. My name is Dr. Kurachi, and in this video we're gonna discuss and talk about the concept of TCP/IP. We're gonna talk about TCP/IP protocol stack and some basic concepts of IP addressing. Now, first of all, protocol means this is the language that both computers they understand, and and this is how they communicate with each other over internet or even the network. And we'll be talking just about the TCP/IP, which is Transmission Control Protocol, Internet Protocol. Now, there are four layers. The first layer is the network layer. This is the bottom layer, which, this layer represents the physical network pathway and the network interface card. Here we have the internet layer. This one uses IP addresses to route packets to the correct destination network. Here we have the transport. This is basically a layer responsible for getting data packets to and from application layer by using port numbers. And also it verifies the packet delivery by using acknowledgement. And finally, we have the application. This is the layer that includes a lot of network services and connection to the client software. Now, the first one here, when we talk about the application layer, this is the application layer, that the one that is closest to the end user, which means that the application layer and the user, they interact together basically through a software application, such as the web browser, you know this is our email client, and so on. Now, the functions of application layer are basically, okay, it's like, think about it, it's like an interface between user application and the network protocols. It basically support different type of protocols, which, like, a lot of these protocols can be very specific to, like, to certain application, like for example, like HTTP for web browsing, SMTP for email, FTP for file transfer, and so on. So in addition to this, the application layer handles the formatting and encryption of the data for transmission, and of course it has a mechanism for user authentication and authorization. It verifies the identity of users or devices and determine their access rights to resources and services. Now, here just a quick example of, for example, like Secure Shell enables users to securely log in to the remote server and issue commands interactively. Here we have the telnet also, the protocol in application layer, which basically, like, you need to have a telnet application that interacts with the telnet protocol inside the application layer to enable users to insecurely, of course, to log on to a remote server and issue commands. And the same thing applies for FTP, file transfer protocol. There's a protocol inside the application layer which allows different operating system to transfer files between one to another. Now, the second layer, the transport layer, okay, this is one responsible for forming data segment. Each one of these segments has a header and a payload information here. Now, inside each header, you find there's a source and destination ports. Now, this layer is responsible for establishing a temporary communication session between two different application and ensure the delivery of the data, okay, between them. Now, there's also the transport layer ensure reliable data delivery by implementing mechanisms such as acknowledgement, sequence numbers, and retransmission. This, if you're using, of course, the TCP. Okay, which is we're gonna talk about the difference between them. Now, also the transport layer regulates the data flow between the sender and the receiver to prevent overwhelming the receiving device. It uses technique they call it the sliding window protocol to manage the amount of data sent and the rate at which it is sent. Now, the transport layer, uh, in order to prevent congestion, the transport layer uses congestion control algorithms to monitor the network state and adjust data transmission accordingly. Now, there are two major protocols within the TCP, within the transport layer. The first one is the TCP, Transmission Control Protocol. The other one is the User Datagram Protocol. Now, uh, we know by now that the connection oriented, okay, is because it ensures the proper delivery of the packet between application and application. Now, the user datagram protocol UDP, it's a connectionless, and here when you use TCP, we ensure reliable data stream. On the contrary, UDP reduce latency and does not ensure reliable data stream. Both of them we'll talk about in more details later on. Now, here we have, if you look at the screen here we have the three-way handshake, and here you could see that computer A sent sync or synchronize packet to the other end, or like a server, for example, and the server will respond with the sync acknowledge, and then here we have the computer A replies back with acknowledgement, and then after after the three-way handshake has been completed successfully, now the two computers will start communicating with each other. you know Now, I want to stress on the important points related to functions of the three-way handshake. First of all, it establishes that the destination device is present on the network. It also verifies that the destination device has an active service, like application that has a service running and accepts requests on the destination port number and the initiating client intends to use. It also informs the destination device that the source client intends to establish a communication session on that port number, and of course, after after the three-way handshake has been done and complete successfully, so right now both of these computers will start sending and receiving data, and then if once they finish, they will get into the termination phase where they terminate the connection between them. And here, if you look at the Wireshark output, here you could see the three-way handshake. And here, this is the packet number, time. Here's the IP address. This is the source. That's the destination. That's the protocol. And that's where it's going from this port to this port and the sync here. And then sync acknowledge. Okay, it will take this information here and reply back to the port, you know and then there will be also acknowledgement, to the port right here also. And here you could see that the information related to the three-way handshake, okay, between the two system together. Now, a critical component of TCP header is the TCP flags and the initial sequence number, ISN, source and destination port numbers. Those, okay, those can be abused by hacker. Now let's go over each one of them. Now the first one, the TCP flags. The TCP header contains various control flags that dictate the behavior of the TCP connection. These flags include the SYN, which is synchronized, the acknowledge, the finish, the reset, and more. Each flag serves as a specific purpose in establishing, maintaining, and terminating the TCP connections. Now, Hackers can manipulate these flags to perform different types of attacks, such as SYN flood attacks or session hijacking. Now, when it comes to the ISN here, ISN is randomly generated number used to initiate a TCP connection. Now, it plays a crucial role in ensuring uniqueness and integrity of the TCP connection. Now, hacker can attempt to predict or manipulate the ISN to launch attacks such as TCP sequence prediction or spoofing, which is still viewed as very difficult, to achieve. Now, the source and destination port numbers here, you know, using the port numbers, to identify the specific processes or application running on a device. See, the source port number represent the application sending the TCP segment, while the destination port number identifies the intended recipient. Now, hackers can exploit the vulnerabilities in application or the services, associated with the application, okay, which is linked to a specific port number to gain unauthorized access or to execute attacks such as like service exploitation or even port scanning. So basically this is how hackers can abuse these components here. Now, here, if you look at it, this is the TCP header. Here, this part is 16, and this is 16. Together, they'll become 32. Here we have the source port, which is only 16-bit. Here we have the destination port, which is also 16-bit. Now, the sequence number, which is a random 32-bit field, which indicates how much data is sent during the session, which is used during the three-way handshake. Now, the acknowledgement number, okay, it's also 32-bit field, which is used by the receiver to request the next TCP segment. Okay, now here we have the offset, okay, which is only small bits, okay. And here we have, those are the flags that we're going to discuss them in little more details, okay. And here we have the window, which is the 16-bit window field, specify how many bytes the receiver is ready to receive, used so that the receiver can tell the sender, that it would like to receive more data than what is currently receiving. Here we have the checksum, which is 16 bits, used for a checksum, uh, just to check if the TCP header is okay or not. Here we have the urgent pointer. This is used when the urgent bit is set. Urgent bit here is set. The urgent pointer is used to indicate where the urgent data ends. And here we have the options field. It can be anywhere between 0 and 32-bit. Now, each now, we talked about the flags, which is right here. These are the flags here. And now, if you look at the flags, now, if the flag is set 0, that means it's not used. Flag 1 means it is used. Now, here we have the SYN flag. For example, it signifies the beginning of the session. And here we have the acknowledge flag, which is, now we could see that it's being used, which acknowledges a connection. And here we have the push flag used to deliver data directly to to the application. Here we have the urgent, which is not used here because it's 0. Okay, this is urgent flag, signify urgent data. Here we have the reset flag, I mean to drop the connection. And finally, we have the finish, which means that connection is finished and time to terminate the connection between the two devices. Now, we already mentioned that the initial sequence number ISN is a 32-bit number. It tracks packets received by the node and allows reassembly of the large packets that have been broken up into a smaller packets as well. And this is really, really important, you know. Also, ISN is sent through steps on 1 and 2 of the TCP three-way handshake. Okay. The sending node ISN is sent with the send packet, the one we mentioned before, and the receiving node ISN is sent back to the sending node with the send acknowledge packet, and this is basically part of the three-way handshake. Now, we did mention that before that uh, that the hacker can take advantage of the sequence number for protection. But in 1999, Microsoft has released a patch that signifies that improves the randomnesses of the TCP initial sequence number, generated by the TCP stack in Windows NT4 that time. And the improving or the improvement in the randomness of the ISN eliminates basically a potential attacks against Windows NT4 system that time. Now, TCP packet has two 16 bits field, contains source and destination port number, as we mentioned, and those ports are considered logical port, not physical component of the TCP connection. It can be assigned to a process or, that requires network connectivity here. Example like HTTPS service, when you turn on the service, it will use port 443 by default. Okay, if you enable, let's say, FTP or service, port 21 will be enabled. So, I mean, which is something important for you to realize, that the more services that is running on the server, the more ports are open for potential attack. So therefore, it is highly recommended to stop or disable unnecessary ports here. And you do have an option, like for example in Windows, you go under services and you say disable these services. Now here we have, I mean, this is just an example, like port 20 and port 21, port 25 for SMTP, for email servers. Also, they could have different ports. Okay, now let's look at the well-known ports here, 0 to 1023. Now these port numbers are reserved for common or popular services, like for example, like a well-defined port like HTTP, it's port 80, you know, or HTTPS port port 443. Okay, and so these are considered a well-known ports. They're very common ports for specific or common server application as well. Here we have the registered ports from 1024 to 49151. These port numbers are assigned by IANA to a requesting entity to use with specific processes or application. Like some company, they want to specify, like let's say port 1812 for radio server authentication process. So a Cisco will, they want this port, they go and register it with IANA here in this case. Now, here we have, those are private or dynamic ports from 49,152 to 65,535. Okay, those are usually assigned port numbers dynamically by the operating system when a connection to a service is initiated. The dynamic ports is then used to identify the client application during the communication. Now, the UDP, if you notice that the head of UDP is pretty much small, and it basically part of the transport layer, used for speed. It does not verify whether the receiver is listening or ready to accept the packets. So this is why UDP does not guarantee the order delivery of the data, And because of this, we cannot guarantee the data will be sent directly there. Okay, now if by the way, like we could take like a DNS use TCP, okay, and it uses UDP. Now DNS uses TCP, let's say for zone transfer between the primary DNS and the secondary DNS. We definitely need reliable data sent between those two, between the primary and the secondary DNS servers, because we cannot afford data not sent correctly. On the other hand, okay, like if you do NS lookup, okay, it will use UDP. You might get an answer, you might not get an answer. Okay, so that this is why UDP is considered as a connectionless protocol. Now let's go back to the header here. So here's the header. Here we have the source port, destination port, and here we have the length, which is basically the length of the UDP, including the header and the data. It is also 16-bit, you know. And here you could see that the checksum, okay, the checksum calculation is not mandatory in UDP comparing to TCP. So it means that there's no error control or flow control is provided by UDP. Okay, so therefore UDP must depend on IP or IC or ICMP for error reporting. Now, just to summarize this, okay, uh, UDP is fast, low overhead, does not require acknowledgement, does not resend lost data, delivers data as it arrives, and that's why it's very good for DNS resolution only. Like if you want to do DNS resolution like NS lookup, as I stated, or it's good for voice over IP. On the contrary, here, okay, SMTP or HTTP or HTTPS, they require TCP because they need reliable connection. So therefore, acknowledgement is important, and it resends lost data and delivers data in sequenced order here. So this is the biggest difference between them. Now, let's look at the internet layer, which routes packets, okay, to a destination address. It uses logical address, IP address. IP address in packet delivery is connectionless here. Now, one example here we have a protocol device within a network. It's the ICMP. Now, the ICMP is used to communicate the problems with data transmission. Basically, one of the primary ways ICP is used is to determine if the data is reaching its destination, okay, and at the right time. This makes ICMP an essential aspect of the error reporting process and testing to see how well a network is transmitting data. However, it can also be used to execute denial of service attacks as well. Now, one of the commands we use to do troubleshooting network connectivity, that utilize ICMP is the ping command. And here we have the trace route command, which tracks the route, a packet that travel from the source IP to the destination IP. And here you could see on the screen when you ping a domain name, and we sent here 4 packets and we received 4 packets. That means, and here by looking at those 4 lines here, we know for sure that that the communication or the packet has reached the destination successfully here, because we have 0 lost here. Now here we have the tracing or trace RT, and here you can see the tracing or from the start here all the way to the end. Here we can see that You could see the number of hops, okay, went through until it reaches the final destination. Now, ICMP type codes. ICMP, there are many type of codes available, but I'll mention some of them here, but there are so many. Like for example, like the type code 5 redirect, type code 8 very common echo. Okay, type 13 times time stamp here. Now, let's look at the IP addressing. In IP addresses, here we have the network address and we have the host addresses. And here, the IP addresses, IP4 obviously can be classified into three classes based on the starting decimal number of the first byte. So we have class A, B, and C. And let's look at this table. Now, this table basically shows you class A, B, and C. That's the basically the range of the network from 1 to 128, from 128 to 191, from 192 to 223. And here, this is the number of the networks. But here you can see the number of hosts is very big. So here we have less number of networks for the class A, but it can accumulate very large number of computers or hosts here. Class B is a medium size, okay. It has this 16,000, at least 16,000 number of networks, and it has 65,584 number of hosts. Now, Class C, okay, this is for small network. Okay, you can have basically many number of networks, over 2 million, but it's good for small size network with limited number of host computers here. Now, let's look at Class A. Okay, here you can see the first byte of Class A address is reserved for network address here. Now, now this is the network address right here. And the other three are basically for the hosts or assigned to host computers. Now, okay, there are obviously very limited number of Class A addresses here, as you could see. Okay, and this is the format network for network, and these are the host 1, 2, and 3 here. Now, Class B, it's divided between the network, okay, and the host computer here. That's 16, that's 14, which is assigned to large corporation and usually to internet service provider. Okay, now Class C, as you can see here we have the network, and network here. So there are three octet network addresses and one for host addresses, resulting in more than 2 million Class C addresses for network. However, it's up to 256 host computers, usually for small size. Now, the second thing I want to talk about, subnetting, which allows a network administrator to divide large networks into smaller segments or subnets. Subnetting concepts are important for performance and security purposes. Now, subnetting allows for efficient allocation and utilization of IP addresses within a network. It takes a large network and divide it into smaller subnets so you can assign IP addresses more effectively and avoid wasting addresses space. Now, this is particularly crucial in a situation where IP address resources are limited, such as in organization with a very large number of devices, you know. Now, subnetting also can enhance network performance by reducing the network, congestion and improving overall efficiency. By segmenting a network into smaller subnets, you can control and manage the traffic flow more effectively. This helps to minimize broadcast traffic and isolate network issues to a specific subnet, preventing them from impacting the whole or the entire network. Now, subnetting plays a vital role in the network security. You know, you could divide the network into subnets and you could create like security boundaries and implement different security measures for each subnet based on their specific needs. For example, you can assign separate subnets for different departments, like for research and development, and then you could implement access controls or firewall rules to restrict unauthorized access between those two or group of subnets. This adds basically an extra layer of security and helps to contain any potential security breaches or attacks within a smaller segment of network. Okay. Also, there's also something else that is important. The subnetting simplifies network management tasks by providing logical divisions within a very large network. See, when you're subnetting, you can logically group devices based on their functions, locations, or department, making it easier to manage and troubleshoot network issues. Additionally, subnetting enables efficient network administration by allowing the delegation of network management responsibility, for example, to a different teams or administrator for specific subnets. Now, the subnet mask here, each network must be assigned a subnet mask, which it helps to distinguish the network address bits from the host address bits. For example, here you can see this is the IP address, and this is the binary that it looks like here. Okay, now this is the subnet mask, which means when you convert this into binary, it's gonna look like this: 255.255.1111, and this is zero, which means the subnet part of the IP address is basically okay this part here. Okay, this side over here. Okay. Now, the host part of the IP address is this one over here. Okay. And here, this one here. Now, IP6, IP4 wasn't designed with security in mind and has caused many current network vulnerabilities. Now, IP6 was used to increase the IP address space and provide additional security. It uses 16 bytes or 128-bit address. And like if you do the conversion here in math, you can imagine how many, addresses it can have. Okay, so security tests also should be aware that all newer OS are configured to enable IP6. However, some router filtering devices, firewalls, and IDS system, especially the old one, are not. Okay, and which makes it easy for hackers to bypass them. Uh, there are just a few things I would like to mention about IP6. It has many features that improve security, such as improving authentication and encryption. It has simplified auto configuration, mechanism that allows devices to automatically configure their own IP addresses. This eliminates the need for manual configuration of IP addresses. Improved routing. Now, the IP6 includes a number of features that improve routing, and also, such as improved support for multicast and broadcast traffic. Now, when it comes to public and private IP addresses, here you could see those are, the private IP addresses. Basically, those are certain block of addresses that you have it at home. Okay, you're using a private IP addresses, and and your router will assign those IP addresses to your systems at home. Okay, and those IP addresses are not unique, by the way, and can be used internally within any network. However, the private addresses are not globally routable, and here you could see those are the network address and the prefix 10.0.0.0, and this is the range of it, and this is for 172.16.00/12, and that's the range, and this and if you try to configure any router at home, you'll find all of them, they start 192.168, you know. So with that, we just, as I stated initially, we just went over TCP concept briefly, okay? And I hope you find this lecture useful, and I want to thank you so much for watching.